Okay, section 6.3. Let's do some homework, but before that, just a little bit of theory. So this is about applications of a normal distribution. So far we discussed the standard normal distribution, but the general normal distribution is when mean is any number mu, not necessarily 0, and the variance is sigma squared, any positive number, not necessarily 1, as it is the case with standard normal distribution. So there is a connection between x and z, if by z we denote the standard normal distribution. So when you have x, if you so x has also bell-shaped curve as density. Okay, and it's symmetric, but not about 0. It's symmetric about mu, wherever mu is. Okay, here is mu, and depending on sigma, it can be more concentrated around mu, or it can be more spread like this. Okay, so anyways, there is a connection between x and z. You can always convert x by simple transformation and get z. Namely, if you subtract mu what you will get is, if this is 0 here, so if here is y-axis, okay, and 0 here, all right, so let me just remove these two. So the effect of subtracting mu is you are getting another random variable which is also with bell-shaped curve, but now you are actually shifting it so that the mean is 0. So that's the effect of subtracting mu. So x minus mu has bell-shaped curve that looks like this. It's located here, all right? And then when you divide by sigma, what you are getting is you are actually scaling so that this bell-shaped curve is now going to be narrower or wider, depending on whether your original sigma is larger or smaller. So so this quantity actually becomes, this random variable actually becomes standard normal distribution, all right? Now, if you only have a table of standard normal distribution for z-scores, for cumulative probabilities, you can make use of it whatever your normal distribution x is. So whatever mu and sigma squared are. Namely, if you want to compute probability that x is less than or equal to some number a, well, that's the same thing as probability. So now what I'm going to do is subtract mu from both sides of this inequality. So x minus mu less than or equal to a minus mu. So all what I did is I subtracted mu. So that's just basic algebra. That's not probability. And then I divide, both sides of inequality by sigma. Okay? So this thing here, so this quantity here is this random variable is my z random variable, the standard normal distribution. And so this is probability that z is less than or equal to this number, whatever this number is. So I compute this number in concrete example, and this is the cumulative probability for standard normal distribution, and so I can use z-scores, the table that we did in that we used in section 6.2. Okay, and similarly you can do probabilities that x falls in between a and b. So again, subtract mu and divide by sigma, or probability that x is greater than some value a or some value b. Okay, now let's see examples. So problem 1 in homework set 6.3, find the area of the shaded region. The graph to the right depicts IQ scores of adults, and those scores are normally distributed with a mean of 100 and a standard deviation of 15. Okay, so we have mean 100 and standard deviation 15, and the question is, what is this area? So what is the probability that this random variable is less than or equal to 125? Now, so we are given that x is normally distributed with mean 100 and variance and standard deviation 15. So since here we usually write variance, so that's going to be 15 squared. Right, let me just double check. Yes. And the question is, what's the probability that x is less than or equal to 125? So that's our question. So what's the probability that x is less than or equal to 125? Now, if you just want to use z table, you would write this as probability that x minus mu, in this case 100, is less than or equal to 125 minus 100. So I just subtracted 100, which is the mean of x, and then divide by sigma, which is 15. So I get the same probability. But now this quantity is z. So this random variable is z, so this is probability that z is less than or equal to, and now this is 125 minus 100, so that's 25 divided by 15, so 25 over 15, so when I cancel by 5, that's like 5/3, so 5/3, so that's actually about 1.666 blah blah blah, and I will put that so it repeats. Okay, so this is a little bit tricky to find using just z table, but you can use z table. So the page 2 for positive z scores, 1.66, so it's actually not 1.66, so it's almost in between 1.66 and 1.67. So 1.66 value is this one, 0.9515, and 1.67 is this one, and it's actually a little bit closer to 1.67. So this probability that you are looking for is going to be somewhere in between these two numbers. And the problem here, in this problem, it says round to 4 decimal places, and because they are asking you to round to 4 decimal places, now you will make a mistake if you just stick to 1.66, but also if you just stick to 1.67. So what is usually done is so-called interpolation. So you need a number 1.66 dot, all right, so 5/3, okay, So that number is, so if you look at 1.66 and 1.67, this number is 1/3 of the distance of the two numbers far from the upper one, and 2/3 far from the lower one. In other words, we can write this number 5/3. Maybe I should write here 5/3. 5/3 as it's in fact 1/3 times 1.66 and plus 2/3 times 1.67, because actually, so that's so-called interpolation. So we have number 1.66 and we have number 1.67, and this number 5/3 is just when you take 166 and add 2/3 of this distance. All right, so this is where number 5/3 is. So it's much closer to this one. So the weight, so we should take into account, so these two values, 166 and 167, we should take into account both of them, but since our number is closer to 167, so the area will be closer to this one than to this one. So how do we weight that? Well, we can just say that the area is going to be the 1/3 times the area that corresponds to this one, and plus 2/3 times the so area that corresponds to this one, plus 2/3 times the area that corresponds to this one. However, this interpolation is rather complicated. I don't want to discuss that in this course. I mean, I did discuss apparently, but I don't insist that you can do this interpolation. So what you can do, just so you know that that's what is done, if you don't have Excel or powerful software, any other powerful software, so you would still make use of standard normal table. But if you don't, if you have Excel, you can do this. So remember, we are looking for probability for getting a number up to 125 of that original random variable x, which actually means probability for a standard normal distribution. So standard normal distribution, let me just write here, to be less than or equal to less than or equal to 5/3. Okay, so somewhere here is 5/3, and what we are looking for is this area here. Okay, this cumulative probability. So we will use norm dist function in Excel. With x, our score is going to be 5/3. I can just write 5/3, 5/3, comma, and now the mean is 0, comma, and standard deviation is 1, okay, and cumulative, yes, so that means 1, and the answer is this. Now, if you actually are using Excel, you don't need to do these transformations and convert to z distribution. What you can do, you can immediately do this, but you just need to specify that your x has normal distribution with mean 100 and standard deviation 15. So what you can do is just norm.dist of 125, comma, and now the mean is 100 and the standard deviation is 15, and cumulative, yes. All right, and you see it is exactly the same number. So I just had to mention, just so you see how complicated it is, if you don't use Excel, but just you see people do these computations without powerful software, just using standard Z table, table for standard normal distribution, and they can find probability for any normal distribution of any mean and any variance or standard deviation. Okay, so in our case the answer is this, control copy, and I just put it here, control V, and so since I need to round to the nearest fourth decimal place, so it looks like I could be fine if I just chop after 2. Okay, and that's the correct answer. Let's do number 3. Find the indicated IQ scores. So now I'm going to do I'm going to do this. We are given. I'm not going to mess up with the Z scores. I'm just going to use Excel. But here, well, let me change the exercise. So, so similar exercise. So the normal distribution is 100, so IQ scores normally distributed with mean 100 and standard deviation 15, all right? And the question is, what should be X here so that this probability is 0.7? Well, if this green shaded area is 0.7, so that means that this one below X is 0.3. So what we are looking for is X value that corresponds to cumulative probability 0.3. Okay, so for that we can just use norm inv, so inverse of normal, so norm dot in, okay, and we are looking for X score that corresponds to cumulative probability 0.3. What did we say? 0.3, right? Yes, 0.3. Okay. So 0.3 is the probability, and the mean is 100. So I don't need to convert to Z scores, which I could do if I only have Z table for standard normal distribution, but since I have Excel, I'm going to make use of that powerful software. So a mean is 100 and standard deviation is 15, so the X score is 92 point blah blah blah. So control copy and control V, and it says round to 1 decimal place. So since the second decimal is 3, I just chop. Okay. Next problem. A survey found that women's heights are normally distributed with mean 63.4 inches and standard deviation 2.2 inches. A branch of the military requires women's heights to be between 58 and 80 inches. Part A. Find the percentage of women meeting the height requirements. Okay. Are many women being denied the opportunity to join this branch of the military because they are too short or too tall? So let's see. The percentage of women who meet the height requirement. So we have the normal distribution with the mean 63.4 and standard deviation 2.2. and standard deviation 2.2, so 2.2 squared, that's okay. So it's not quite symmetric. Okay, so this number is 63.4. That's the mean. So that's the center of symmetry for this bell-shaped curve. Okay, and now we have that the criterion for this military branch of military is that the height should be between 58 and 80. 58 and 80, so somewhere here is 58 and somewhere here is 80. Okay, and what proportion of women falls into this region? Okay, so we are actually looking for this area. Okay, so it's going to be cumulative from minus infinity up to 80, and then minus this area, this cumulative area, from minus infinity up to 58. Okay, that's how we are going to compute it. Okay, so let me this cell equals norm dot dist of, now the value x, I first want 80, so 80, comma, standard deviation, so that's mean, that's 63.4, 63.4, standard deviation is 2.2, cumulative, yes, okay. So that's this blue plus red area, and now minus the blue area, so minus norm dist, the number is 58, the mean is again 63.4, and the standard deviation again is 2.2, and the cumulative again, yes, okay. So this is the value. Control copy and Control V, but since this is supposed to be in percentages, so I need to multiply by 100, so it's 99.29 blah blah blah, and I need to round to 2 decimal places, so it's 0.29. Okay, are many women being denied? Well, 99.29% fall into this region. So the women that are denied according to height criterion are just so it's less than 1%, just 0.71%. So it's really low. So it's a really low number, 0.0071. Okay, so no, because the percentage of women who meet the height requirement is fairly small, so that's wrong. So no, because only a small percentage of women are not allowed to join. So this is the right answer. So just a second, I should have move this. So the offered answers are no, because the percentage of women who meet the height requirement is fairly small. That's obviously, I mean, it's obviously that it's not fairly small, it's actually fairly large. Because, so B is because, yes, because a large percentage of women are not allowed to join this branch, so obviously that's not, first of all, it should not be yes, and C should not be yes. So D, no, because only a small percentage of women are not allowed, so that's the correct answer, so D. Okay, and part B, for the new height requirements, this branch, okay, so in part B, if this branch of military changes the height requirement, so they change criterion, so that all women are eligible except the shortest 1%, so the shortest 1% and the tallest 2%. What are the new height requirements? So the shortest 1% and tallest 2%. So okay, I usually use black pen. Okay, so here is what, 63.4. So again we deal with the same population of women, so normally distributed, mean 63.5 inches and standard deviation 2.2. Okay, but now we will reject only shortest 1% and tallest 2%. So that means this part here, which is only 1%. So 1%, so that means 0.01. So that's 1%. And highest 2%, so let's say somewhere here. So this probability is 2%. Oops. So 2%, or in other words 0.02. Okay, so the question is, what are these numbers, this one and this one? Okay, so that will be new criterion. So everybody who falls into this region will meet the new criterion. Okay, so we need to find this number. So this number is obviously we will use inverse probability, so norm inv of value 0.01. Okay, so inverse cumulative probability 0.01, so equals norm dot inv of probability is 0.01 and mean is 63.4 and standard deviation 2.2, and that's it. Okay, all right, and so that's this number 50. So let me see, how do they round? They round to 1 decimal place. Okay, so when we round this number to 1 decimal place, so it's 58.3. So I will write here, so 58.3. And the other one, so we can still use inverse cumulative distribution, so the probability up to here, because upper tail is 2%, so the lower part is 98%, so this area here is 0.98, the cumulative distribution, so the cumulative probability. So what is the X score that corresponds to cumulative probability 0.98? That's our question. So norm dot inv of 0.98, comma, mean is 63.4. Let me just check whether it's 63.4. Yes, and deviation 2.2. Okay, So 63.4 comma 2.2. Okay, and that's our value. Let me just check both of them. Yes and yes. Okay, so when we round this one to the nearest decimal, so it's 67.9. So here we have 67.9. So that should be a new boundaries or new criterion, updated criterion. So for the new height requirements, this branch of the military requires women's heights to be at least 58.3 and at most 67.9. Okay. All right, that's section 6.3.